Morning, everybody. Quick turnaround on this one. In actuality, I've been recording bits and pieces for this video for a couple weeks now. I got a lot going on, despite the fact that the garage is in shambles. On the upside, I just got word that the landlord came by and patched and painted the wall and the ceiling. So I'm going over there now to check that out. Hopefully, once the paint, the vapors and stuff go away, I'll be able to get my workbench back in the corner and get set up again and really be productive this weekend. Hopefully, I don't know, maybe I'll have to set up a couple fans to get some of the fumes out. But we'll see how that goes. Looking good, looking good. I don't know why they left all their stuff here. Garbage bag over here. Guess they're coming back for that Monday. I don't know. But the ceiling's painted. Wall's painted. I got paint all over my rack, but I was planning on painting that white anyway. I'm good to go. Finally, I can get the tent off of the Jeep so I can take it home. It's been about 2 months since I've driven the Jeep because I can't fit it in the garage at home with the tent on top. But I can finally get my table back over here and get situated and get back to work. So you remember the end of the last video when I discovered how relays are really supposed to work and what I had been doing wrong, and I retraced all the problems with my wiring and came up with a really cool game plan. Well, since then I bought some heavy duty waterproof relays, and I got one of the 2 rocker switches I was looking for, and they've pretty much been sitting on my shelf ever since then, and that's where they're gonna stay. I decided to get a little bit more technical. Now it's been a long, sort of drawn out process since that last video, but I'm gonna try and go through this chronologically so it makes sense. So I bought this one first. This is the Auxbeam switch panel system. When I was researching and shopping for relays and toggle switches and stuff, I came across this. This basically has built-in relays. It's a pretty much solid state unit. It has fuses, but all the relays are built into this module here. So I won't need to use these expensive relays that I wasted my money on. I got this backwards. So this is a pretty cool system. It's made in China, but it seems pretty solid. It's a decent looking system. It's got switch pan. This basically replaces 8 separate toggle switches in this one little pad here. And as I said, the relays are all built into here. So this would have 8 switches for 8 different accessories. Comes with a breaker box here. There's been mixed reviews on YouTube about these and on Amazon too. They apparently, it looks like they may have redesigned it, but the old design, I guess this cover was, this sort of build out on the cover was too low, and so when you put the cover on, it actually trips the breaker. So I don't know. It seems like it would clear it just fine on this one. Maybe it's something they addressed after the fact. But this comes with bracketry and the wiring and everything you need to wire up 8 different accessories. So when I got on YouTube and started researching the install process for this and reading reviews and stuff, it all seemed good, but as it always does, the YouTube algorithm sent me on a journey of switch panel systems, and that sort of led me away from this to something a little bit more professional and specific. So after overcoming the initial sticker shock, I picked up a SP9100 by Switch-Pros. Like the Auxbeam, this one alleviates the need for relays, but this one also alleviates the need for fuses. All that stuff is built into the module, and it's also fully programmable. Well, to a certain degree. I thought that this was going to be more programmable than it actually is, and so that sort of led me into an issue once I bought it. Once I got it home, I set up a sort of a test board, not unlike the one that that Switch-Pros displayed on the GenRight YouTube channel. They do a weekly sort of presentation on different products and stuff, and they had Switch-Pros on, and they set up this really cool, actually dual switchboards set up on this display, and they showed what the top of the line system does, which is the RCR Force 12, and then they showed what this one does. And unfortunately, I wasn't really paying enough attention at the time. I was just sort of so amazed by the programming capabilities and the capacities of both systems that I thought that they actually had the same functions, and the difference was the capacity, the how much power they can put out, but that's actually not the case. So after about a week of playing around with the SP9100 and failing to figure out how to get it to do what I needed it to do as far as on, off, and timed switches and stuff like that, the things that I really needed to do for my build, I contacted Switch-Pros. And let me say right here that these guys have the best customer service I've ever dealt with. I sent them an email, and I think they got back to me within a couple hours, and we went back and forth at rapid pace, and they answered all my questions. Unfortunately, they answered some questions that I was hoping that they would answer differently, but it turned out that the 9100 is actually not capable of the functions that I was trying to get out of it, and for those functions I needed to go with the RCR Force 12. So I was forced to endure another dose of sticker shock, and I just went ahead and got the RCR Force 12. So here goes. It's like Christmas morning. There's my button decals. Lots of good stuff in there. Instructions. The instructions for the SP9100 are really thorough. I'm sure they're going to be the same for this one. Oh, here's the module. Look at that. Even got a fingerprint on there. That is beautiful. Aluminum. That's what it's all about right there. That's what it's all about. Whenever and wherever you can support that, do it. There's the switch panel. 12 clicky switches. I'm gonna have to figure out a good spot for this. That should take some thought. I'm thinking over my center console where my old toggle switches were, but I'm gonna have to mount it at an angle. And this is the communications wire that goes from the switch panel to the module. And here are the high power lines. These, unlike the RCR, unlike the SP9100, this one has these high power lines, and you would use these for compressors and you know, the higher output stuff. And I got the positive cable. There's a big fuse in there, I'm sure. I should, after this, I think I'll do a comparison, an unbox comparison maybe. Actually, it won't be a full unbox because the 9100 is actually set up on my test board, so I won't be able to really, I'm not going to take it all apart to put it back in the box. But so this one, the RCR Racer, they call it the Racer Force 12, comes with this sort of touch sensitive panel that fits over top here. So if you're, you know, on the bumpy, you can feel the buttons. So it makes it easier to locate the buttons, I suppose. It's kind of cool. That didn't come with the 9100, but you get it for your money on this one. And odds and ends for running the wiring. There's the, I can't quite understand why they go to the trouble of adding this. I'm not sure how this is really even that helpful. I don't know, maybe I'm missing something. But. And here is the wiring to the accessories, the lower draw accessories. And trigger wires, and the size of this loom compared to the 9100 is, this one is a lot thicker. This is pretty substantial compared to the 9100. So I'm gonna have my hands full this weekend. I'm gonna be playing with this. I think what I'm gonna do is wire this in tandem with the 9100 into this test board that I built for the 9100 so I could test the functionality on the 9100. All right, here we go. The definitive Switch-Pros component comparison review. So on the left side, I got SP9100. On the right side is the RCR Force 12. These are the two kits that are available. There are some components here that are actually shared between the two kits. So I'll talk about those first. First off, the mounting brackets. I'm assuming these are vehicle specific. I'm not going to end up using them in my TJ, but those are shared between the two kits. Sticker sheets. These are all the same stickers, 2 sheets. I think there's 100 stickers on each sheet, so 200 stickers between the two kits, or 200. The COM cables, despite the fact that the RCR12 has 12 buttons and the 9100 has 8, the COM cables that run from the switch pads to the modules seem to be the same cable. I'm gonna have to check the spec to make sure of that, but based on what they look like right here, I'm gonna say they're probably the same cable. So now for the differences. So obviously the RCR Force 12 is a much higher capacity kit. This is a 150 amp kit where the 9100 is a 125 amp kit. So the size of the modules is different. The RCR Force 12 is much bigger. You can see, and it's also got an extra port. And the power cables, for the RCR Force 12, there's a 2 gauge cable with a 150 amp inline fuse, whereas the 9100 has what looks to be a 4-gauge cable. I'm going to say this is 4-gauge. I don't see it on here. I'm going to say this is a 4-gauge cable with 125 amp inline fuse. So then we got the wire looms. The wire looms for the RCR Force 12 are slightly bigger, only because the harnesses are bigger because they're carrying more function and more power than the SP9100. So switch harnesses, as I just said, the switch harness for the RCR Force 12 is considerably bigger than the one for the 9100. So you can see the difference in the plug sizes. And the RCR Force 12 also has this extra port here for the high draw switches. I think they're 1 through 4. This is, I believe, 10-gauge wire. So this is a lot thicker than the smaller, capacity switches. So this is going to be for cooling fans and higher draw situations like that. So other than that, the installation kits, obviously the brackets are included in the installation kit, the brackets to hold the keypad, so they're going to be slightly bigger for the RCR Force 12 than the 9100. But other than that, I mean, these are just miscellaneous electrical connections. The RCR Force 12 probably has a few more because there are more switches to hook up. But other than that, I believe that's pretty much it. All right, so I got my battery tray back. Unfortunately, there's a few issues. Nothing really that big. For starters, I let him take some liberties to save time. I originally spec'd these battery poles and the battery call out, the part numbers to be beveled out, but I let him switch it to engravings. That saved me probably some time and money. These look really nice. These came out good. But one thing that, by the way, these are mistakes or things that I overlooked, not the machine shop. They did a good job. Despite the fact that the guy in the machine shop ended up with COVID, I think, just before he started my project. But one thing that I missed somehow in all my sketching and sketch models and stuff, if you look at the distance between this is where the battery hold down strap is going to go through. So if you look at the distance from the bottom edge of this hoop to the beginning of where the relief cut is, so this is the relief cut where this whole tab is going to bend up 90 degrees. If you look at that distance, for some reason I skated this wire access hole, for lack of better words. I skated this down to, this is only maybe 2.5 mil from the bottom edge to the edge of the relief cut. I don't know why I did that. I don't know why I didn't move this up to even with that. It doesn't really make a whole lot of sense to have this one all the way up here and this one here. And so that is gonna possibly cause a problem when I try and bend this flap up. And another problem is my relief cuts. I didn't spec my relief cuts deep enough. I should have gone at least 50% of the material, the plate depth. This is 5 mil plate, and I should have gone at least 2.5. And for that reason, and for the reason of these being so close to the edge of the relief cut, I'm not even going to try. Yeah, see the logo here has these delicate, I mean, they're not delicate, but You know, these things I could probably wind up twisting or torquing one of these tabs, because this one is only attached there and there. So if I try heating this up and bending it in the vise like I was gonna do originally, I think I risk screwing my logo up or ending up with this flap sort of being twisted, and I want it to be precise. I've gone to all this trouble so far, so I'm going to take it back to the alley where the machine shop is. There's a couple of other shops that have giant industrial brakes, so I'm going to just take it to them, tell them 90 degrees, and have them bang it out in probably 5 minutes, and save myself the trouble. Well, it didn't go as expected. Unfortunately, out of the 3 bends that I needed, they were only able to bend 1, which is the one for the shunt. Apparently, the material on both my center bend points is too narrow. It's not long enough to reach all the way across the channel on the brake. So another problem was that the relief cuts I made could actually damage the machine. So I ended up back with plan A. I took my angle grinder and dug the 2 relief cuts a little bit deeper. Another issue I had was once I got close to 90 degrees on the first bend, I realized that the relief cut was actually too narrow. Thankfully, I was still able to sneak my angle grinder in there with a cutoff wheel and clearance it out and get it to 90 degrees, but I made absolute sure that my relief cut was wide enough on the second bend, so that one went a lot easier. In hindsight, I probably could have gone a little bit deeper on those relief cuts. I really had to fight with this thing to get it bent into shape. So after about 25 minutes of hammer blows, I decided to just respec the tray in 4mm plate. I'm going to use this tray as a sort of test piece to assemble the rest of the project, but this is going to be the new design for the tray. So now I'm working on mounting my shunt for my battery monitor. I designed this so this bends back and I can mount the shunt on here. The screws that the shunt came with are tiny, and I'm not even going to bother with those. What I'm going to do is I've drilled the holes, I've marked the holes and drilled them for M5 by 0.08. So I'm gonna tap the holes so I don't have to worry about reaching behind here and holding nuts.
I want you to think about it long and hard. That's what she said. Don't you dare.
I'll just plop this down on here and put these screws down through the base of this. I'm gonna have to hollow out the base of this a little bit, hone out the base, but I'm not gonna lose enough material that it's gonna be problematic. On a side note, I don't know what kind of cutting oil you get, but this is what I get from the local hardware store, and it's these. It comes with these here, which are a pain in the ass because they leak like a sieve. What I discovered is COVID test tubes make perfect cutting oil dispensers. They have this little cap on here, and you just turn it upside down and give it a tiny little squeeze, and there comes the cutting oil. Works perfectly. Full disclosure, I don't know exactly, I looked it up, I don't know exactly what size drill bit you're supposed to use for an M5 tap in standard size. When I looked it up, it was giving me metric bits, and me being an American and living in Asia, my toolbox is a messy combination of standard, of SAE and metric. So I'm using what I believe is 11/64 bit, and it worked on this side, so I'm just going to go ahead and use it on this other side. I passed it through once, but I just want to clean it out. just a little bit more. Just so I'm not making the tap do too much work. But yeah, I don't know what it is. I got bad luck with taps. It really could be the fact that these taps are just, you know, garbage eBay bought. This is an eBay bought tap set. That could be the problem. I don't know. But we'll see how it goes. Holding my breath. Feels like the tap is grabbing and cutting. It's feeling a little bit more solid now. This thing's moving all over the place. Yeah, I think it's coming through. Oh yeah. We got 2 holes. All right, so for the mounting holes, I'm gonna go a little bit bigger. I got a 3/16 inch bit here, and we'll see how that goes. Just snug that in tight enough to hold on to it. And hope for the best. Nice and easy. Okay. Not that I was expecting it to crack or anything. So, hopefully, yeah. Okay, moment of truth. I still need to clean these holes up with my angle grinder, but I can't do that at this time of night. See if we can get these holes to line up. Looks like they do. Okay. That is sturdy. I'm not even going to worry about this third. There was a third screw that went in there, but I mean this is sturdy enough that this isn't going anywhere. And this bolts onto the bracket like so. Oops. Don't forget the washer. And that's it. All right, so there you have it. Shunt's mounted. Screws only stick down maybe, they only extend maybe a 1/4 inch on the bottom. That's not gonna bother anything. I got some wiring that might end up in here, so maybe I'll put some rubber boots on there or something, but it's probably not gonna be a big deal. I think it's about time for a test fit. Oh. I want to test fit the batteries first. So when I had it machined, I machined the battery part numbers in here. You can see here. So this is getting these 2 baby AGMs. So here's the part numbers here. So this one is AGM 28MJA, which is this one here. And I got the negative pole here. So this one fits on this side, like so. And this marking here, AGM 28LA. And that's this little guy here. And you can't see it in the camera, but when you spin this around, there's a little positive pull mark there. So this one loads up on this side over here. And you can see in the background here, that's where my wires are coming. My positive and negative wires are coming through. The positive wire is going to come from, you know, underneath the belly of the Jeep through the tub, and then through this hole up to the positive on this battery, and then the negative from this battery is going to come back out and up into this shunt here. And this shunt will be wired to my battery monitor. So that's how the batteries will fit up. And now I want to test fit the actual shelf, the actual tray in the Jeep, because I tend to do this compulsively, because you get so far with something and then you realize you made something too long or too short, and then you end up backtracking. So I like to test fit all the time, just so I can sort of stay ahead of the game, stay ahead of the screw ups. But this, yeah, this fits perfect. So sometime this week, I'm hoping I'll be able to get in here, and I need to pull this this bracket that my bench seat mounts on, and I want to weld my battery tray to this bracket to secure the batteries in case of, you know, worst case scenario. And I also want to use this hole here. I'm probably going to drill a hole right up somewhere around this area here, and throw a bolt, sort of a countersunk cap screw. I'm going to throw that down through the tray and bolt it to the bottom of the tub too. So it'll be welded along this seam here and bolted down to the tub right here. So these batteries aren't going anywhere. And the batteries themselves will be strapped down through these hoops here. You can see these hoops. I got nylon straps that are, I forget what they're rated at, some, you know, insane amount of weight. So that they're gonna come up over the battery and then go through these hoops back here. So the batteries aren't going anywhere. Doing a good job?